All right, our last thrilling example is about orthogonal trajectories. And I know you can hardly wait to hear about this, so I'll just dive right in. Two graphs are orthogonal if at their points of intersection, their tangent lines are perpendicular to each other. Now, I think I could probably read that to you all day and you wouldn't really know what I was talking about. So I thought that I would go ahead and show you our example on a graphing calculator on Desmos so you can see maybe a little bit more of what I'm talking about. So our two equations that we're going to be looking at are right here: y squared equals x to the third, and 2x squared plus 3y squared equals 5. So I'm going to switch to Desmos right now. I already have them graphed. The pink graph is y squared equals x to the third, and that is kind of an unusual shape here. And then we have an ellipse, a little bit more familiar to you, in blue. That's the 2x squared plus 3y squared equals 5. So what we're going to be determining is whether or not these two graphs are orthogonal, which means that at their points of intersection, so at 1, 1 and at 1, negative 1, their tangent lines have to be perpendicular to each other. So you can imagine the tangent line being drawn on this ellipse, and then the tangent line, which would be a little harder to draw, but the tangent line drawn on this y squared equals x to the third, on that graph, those two tangent lines, if they are perpendicular to each other, then these two graphs are orthogonal at 1, 1. And then we would also look at the tangent line here at 1, negative 1, and the tangent line for our pink graph at 1, negative 1, and see if those are perpendicular to each other. And if so, then it's orthogonal at 1, negative 1. So fortunately, we don't have to find the equations of that line or equations of those tangent lines, but we are going to need to do the derivative and compare their slopes. And really, that is not a difficult task. So I'm going to ask you to find the derivative implicitly. So you'll find my first equation, y squared equals x to the third. I did the derivative. So you've got, for the y, you have 2y, and then because it's a y, you have dy dx, and then for your x, you have 3x squared. So solving for dy dx, this is our derivative for that first graph. And then for your second graph, you have 2x to the second. So that derivative would become 4x. And then 3y to the second. So that derivative would be 6y. And because it's a y, you'd have dy dx. And then your derivative of 5, which would be 0. So we could subtract 4x over and divide by 6y. Simplifying, we get our derivative of that second graph at negative 2x over 3y. So now your job is to compare the slopes. And so that's what part D is. So we're going to look at each point of intersection. So this work and our conclusion is for the ordered pair 1, 1. So we're looking at where the two graphs intersected. If you think back to the Desmos graph, one of the points of intersection was at 1, 1. So if I substitute in to my derivative, so remember I had, and I'm going to color code it for you. So for my derivative that I found first, plugging in 1, 1, I would get a slope of 3/2. And then for my derivative that I found second, this would be the one down here in red, substituting in my 1, 1, I get a slope of negative 2/3. So are those slopes opposite reciprocals? Yes, thank goodness. And so the tangent lines are perpendicular because the slopes are opposite reciprocals, and therefore the graphs are orthogonal at 1, 1. And then scrolling up, we can look at, so I'm going to clear the ink. We can look at the other, oh, sorry about that. We can look at the other ordered pair. So at the other point of intersection, which was 1 and negative 1. So we had our, I'm going to make this screen just a little bit smaller so you can see. We had our first equation. We found the derivative, and so we can substitute in 1 and negative 1. We find that our slopes are 3 over negative 2. And then our next equation's derivative was negative 2x over 3y. That work is shown right here. Substituting in 1 and negative 1, we get a slope of 2/3. So are those opposite reciprocals? Yes. Negative 3/2 and positive 2/3 are. And so therefore the tangent lines are perpendicular and the graphs are orthogonal at 1, negative 1. So the concept is much, much harder than the actual work. You just need to find their derivatives and then substitute in those points of intersection. So be sure that you use a graphing calculator. I'm going to scroll up and let you see just a little bit of the graph. It was hard to get the both graphs to show up, but what you're seeing here are those tangent lines. So the tangent lines are perpendicular to each other, and I have that at both the 1, 1 and the 1, negative 1. So those are your 3 examples, and this implicit differentiation assignment is one that's going to have a lot of algebra for you, so make sure that you get started on that.